Thanks a lot, Harald. And yeah, just to summarize the concept. So we are doing this market report once a year. It is mainly a service to the members, but we also obviously want the spreading or the growth of the biochar market to be well known by politicians. This webinar is EBI only meeting, and the recording will likely also only make available to the EBI members. This being said, we will have multiple meetings with politicians and other important stakeholders where we will then transport the main messages from this report. So I will I have quite a lot of slides. Many of them are pictures, and I actually like to start to give you a few impressions on how the technology evolved, and to represent that, I just collected a couple of nice pictures I got from our members, and I will just quickly skim through these pictures to show you what's going on and what kind of plants and what the technology looks like and feels like. These are, and I'd like to invite you as members to send nice photos to EBI, which we will then be able to use in our presentations to represent, to show that biochar, that this is high tech, that this is leading edge technology, and that this is not kind of making a campfire in your backyard. And let me now start with the introduction. I mean, obviously, you know all that, but what you might not fully be aware of, that we have a new branding, a new wording of on how we talk about the carbon capture service. So we will not use any more PUCs. We will now use, and that was a result of a members or discussion process within members in the policy working group, where we defined the term biochar carbon removal and abbreviated BCR. And you will see that term being used already in the presentation, and it represents the whole process of the biomass creation, the biochar production, its refinement, and then its use in carbon preserving applications. Now, I'd like to take a look at the balances, at the carbon balances, and on the energy. So if we have biomass, that is valid for a technology that is optimized for biochar yield and not for energy. We'll have roughly 50% of the carbon that is in the biomass going into the biochar, and the other 50% going into energy. And we're now looking not at the energy, but we are always aware, and we have to be aware, that energy production is a key element to biochar production. And we'll look what can happen with this biochar. And that is important because we see that the industry has kind of changed a little bit to a broader variety of applications of biochar. I mean, so we have biochar, and in theory, that could be burned in a fossil fired power plant instead of coal. Then we have the second application, that is use of the carbon in the metallurgic industry. And the third one is the carbon preserving application, where the biochar is used in the three applications, the key main applications: agriculture, urban, or materials. Now, let's look at the CO2 balance of these three potential pathways the char could go. So first, we look at the energy usage. Well, obviously, this is not carbon removal because the carbon will be converted into CO2, but it saves some emissions, but not that much, because I mean, the only way of reasonably considering that, when we have 1 ton of biochar and it is converted into energy, kind of the competition, the alternative is, well, the electricity, for example, in the grid, or a heat pump. So we can't use kind of the replacement of fossil coal, because fossil coal will go away. So we have to look at the average emission of energy, and then this ton of biochar replaces maybe roughly 1 ton of CO2. Totally different when we go to metallurgy. Same here, it's not carbon removal, but if there is a metallurgic process where the producer needs carbon because he wants to get the oxygen out of his metal, then, I mean, there are only two options. Either it is fossil carbon or it's biogenic carbon. So this way, there is clearly a true carbon emission avoided in the amount of 2.5 to 3 tons per ton of biochar. And then the other, I mean, that is easy. We know all that. If we use the biochar in a carbon preserving application, we have carbon removal of 2.5 to 3 tons of CO2. And remind that we're only looking at the carbon side. We're not looking at the energy side of the biochar production in this slide. So looking at the CO2, what came to my mind is just showing it this way, that, I mean, CO2 obviously is composed of CO2, and 1 ton of carbon contains 3.6 tons of CO2. But carbon is not the problem, nor is O2 the problem. The problem is with CO2. And then it seems to be obvious that it might be smarter to deal with C rather than dealing with CO2. So we kind of discussed a lot and found this sentence here, that tackling the problem at its root means preventing carbon atoms from becoming CO2 molecules. And to visualize that once again, so we look at the carbon that is inside of the biomass, and that is roughly between 30 to 50%. Let's take 40% as a representative. Now, if we burn the biomass, we get carbon in the exhaust gas in the amount of about 4.4%. And if it gets diluted into CO2 in the atmosphere, the amount of carbon is 0.01%, as opposed to biochar, where we concentrate the carbon up. So once again, we discussed a lot. And what does it mean? It means that if we avoid combustion, that prevents dilution of carbon by a factor of 10 up to a factor of 4,000. And on the other hand, carbonizing biomass concentrates carbon up by a factor of 2. So I just wanted to give that as a quick intro to where we are going to. And what is important, and what I will state that later once again, we see that the range of biomass that is used for carbonization is diversifying. So we have the forestry residue wood, we have crop residues or residues from the food industry, demolition wood, old that is normally burned. Then in Scandinavia, I know it's a lot, or in the Nordic countries in general, I know there is a lot of pressure on maritime biomass, which creates a lot of problem. And last but not least, we have sewage sludge, where there is quite some interesting movement in several countries. Well, and then that's the other side of the application. It is of the biomass provision is the application with the main pillars: urban application, agriculture, and construction material. Now, I'm happy to show you this slide, and as you recall, having seen these slides before, you will see that it's getting crowded, and I'm very happy that it's getting crowded, because when we were in Brussels a year ago, when we showed a slide that was less crowded, we heard very, very good feedback from politicians and consultants that having or being the representative of many companies really makes us the voice of the biochar industry. And this way, when we look at our members, we see that more than 60% of the members are either, so today we are 82 members, kind of changing every couple of days. We are 82 members right now, and about 60–70% are either equipment manufacturers or plant operators or companies that are planning to or are in the process of installing a biochar production unit. Then on the main pillars of EBI, I just spoke about Brussels and policy. About a year ago, we started to become much more active in Brussels, and that has been very successful in a way, resulting in a key success that Harald is representative of the carbon removal expert group, which is very important. Then on the right side, we have the pillars industry standards, where we work with others, together with a lot with the EBC. And then we have communication. And today's task is market intelligence. And so I'd like to introduce and start really now to begin with a market report. And I'd like to start with thanking the key contributors to this report: Lea Hettich, Matthias Gustafsson, the Nordic Biochar Network, the equipment manufacturers and plant operators, the policy working group, and many other EBI members, biochar experts and stakeholders. And it was a pleasure for me to lead this initiative to compile this report. And then I would like to thank the two sponsors of that marketing report, Carbon Future and South Pole. Carbon Future being the platform for high quality and impactful removal credits with, I would say, a highly sophisticated MRV system that is one key element to the carbon removal industry, because it's the basis to be able to trust the carbon removal credits. And then I would like to thank South Pole. South Pole being a key player in the climate, in the carbon removal industry, providing finance to biochar projects, but also other projects. South Pole is a member since last year, and so I'm glad to have them on board with all their expertise on how to finance this, because and you will see that we have a huge challenge in front of us, because we have to grow this to a significant industry. So now to the main agenda of the report. Yes, so starting with motivation and the scope, I will do that very brief. Then we have the biochar manufacturing equipment, then the ultimate report, and then I would show how we scale that to climate relevance. And I start with the motivation and the scope, respectively. And I will not show all the slides that are in the slide deck that will be published next week, and that will not be published only to EBI members, but to the broad general. So to the scope, what do we look at? We look at biochar that is produced in plants in Europe until the end of 2022, and installations that will be commissioned in 2023. So that is the scope of the plant. And we look at all kind of carbonized biomass that is suitable for applications in soils and materials, whether be it a production plant, a pyrolysis machine that is used to produce biochar only, but also plants that were used or are used also to produce charcoal, or carbon for the metallurgic industry. And that in a way is, so there's a much stronger focus now, because we see that these plants are, are being built or are being rededicated to carbon preserving use of the carbon. And so we define categories in terms of production volumes. These are small, medium, large. And the method for calculating the production capacity is that we use for these plants up until 2,000 tons, unless we knew differently. Our assumption was that all the biochar produced goes into the carbon preserving applications. And then for the very large and the industrial installations, we made quite an effort to understand what is the percentage of the carbon produced that is used for biochar in the sense of carbon preserving application, and which percentage is used in for metallurgic industry and barbecue energy. So when we talk about biochar and biochar production potential, we always only refer to that part that is dedicated to the application in carbon preserving applications. Now we come to the manufacturing equipment, and I will do that really fast. It's not about to highlight single companies. The impressive thing is that the industry has grown tremendously. There are existing players that are partially around since many, many years, and having installations up to 30 equipments installed and more. There are more and more companies coming there. There are very different types of equipments. There are large ones, there are small ones that are dedicated or specialized to sewage sludge or other materials. There are more and more players coming in. There are players coming in there in the energy business for quite a while, and that have extensive experience in building these kinds of manufacturing plants. So pretty dynamic space, and in a way that is also represented by the fact that in the EBI, we're growing in the EBI quite nicely. Now, coming to the real numbers and the amount of biochar. So what you see here is the number of biochar production plants, pyrolysis plants, that have been installed in the year 2020. That's the red bar, or the red framed bar. So that is 28 biochar production plants that have been installed and commissioned in 2022. So, well, you might remember that a year ago, at a very similar time in the year, I had presented last year's report, and where we had 44 projects on our radar for 2022 completion. And so we analyzed that in deep, what happened, and we saw that that 15 of them moved to 2023, 4 of them slipped even a year more, or have been canceled. But on the other side, there were 3 projects we hadn't on our radar that were installed. But clearly the 15 that have not been commissioned in 2023, those for sure will be installed in 2020. The 15 that were not commissioned last year will be commissioned this year. So coming to the expectation, and I would say we had been a bit stricter on what we put into the projection for 2023. And we moved even some projects where people told us, yeah, it'll go online in Q4 this year. And in that case, in several occasions, we then didn't even put them in 2023, but moved them already anticipated into 2024. So I have quite a good confidence level that we can reach this level of close of 50 or even above projects. So, and that was annual installation. What you see here now is the cumulative installation of pyrolysis plants in Europe. So by end of 2022, the installations there were 180 plants in our databases, and that with a 50 more we expect might grow to 180 by the end of this year. And I would also like to mention that there are many projects that are in an advanced planning and permitting process for 2024. And this is also one observation. I mean, plants are generally getting a bit larger. And that also means that permitting and planning and procurement and everything tends to be a bit longer than it was in the past with the smaller plants. Now, moving from number of installations to production capacity. And I would like to reiterate here that the amount of biochar that you can see here as production capacity, that does obviously not include if there is a large charcoal producer that dedicates a small fraction of his, or a fraction or a small fraction or whatever, of his production to biochar usage. So in that case, we only count for the biochar dedicated usage. And we see that the market grew by 52% to 53,000 tons of biochar production capacity. And now, most of you had seen that before, that we always analyze the growth rates, because this is really where you can learn how fast the industry is growing and how fast it can grow in future. So we see that we are in pretty impressive ranges of growth. The 3 years average growth rate was 56% from 2019 to 2022. And if the 51 plants get installed, we will move up to more than 90,000 tons of biochar production and a growth rate above 80%. So I'm really curious. I mean, I know of quite a number of plants that are either already commissioned this year or are in an advanced installation process. So we will be very curious to see if that projection gets through. We will move up the gross average sales rate to 68% in 1 year from now. Now, production capacity is one thing, actual biochar production another. So we made, in order to estimate how do we come from the production capacity to actual biochar production, we made the following slightly revised assumptions compared to last year. So our assumption is that for a plant that is commissioned this year, we use a 6 month of operation, kind of in average. The plant goes in operation on July 1st. But in the first year, we don't assume a very high uptime, but only 60%. So in a way, everything that gets added from 1 year to another only accounts for 30% of its capacity. And for plants that are operational already, or that have been commissioned in a previous year, we obviously use 12 months operation and 80% uptime. And the uptime calculation is based on a typical uptime of the plant of 8,000 hours. So this is not 8,640 hours times 80, but it's 80% of the full load hours the producers typically give, and that is typically 7,500 or 8,000 hours. So if we do all that, we come to a biochar production in 2022 in the amount of 33,500 tons of biochar, and that is dry mass, by the way. And that is equivalent to almost to more than 90,000 tons of CO2 removal. And therefore, I think we can clearly say that biochar carbon removal is by far today's most relevant technical carbon removal technology. And going forward, and assuming that the 51 projects are being built this year, we will end up at a production above 50,000 tons of biochar and with a carbon removal potential of 150,000 tons of CO2. Looking at the distribution of the production units or of the production in terms of size. So this is the basis is the tonnage of biochar. I want to go quickly through that. So we see that the categories medium, large, very large are the biggest one, and industrial is also quite significant, and it's growing. Looking to the countries where the biochar is being produced, we have 3 strong regions. One is Germany, the other is Austria and Switzerland, and the third one is Nordic. And over the last years, that is pretty constant that the production in these 3 countries form roughly 75% of the total production in Europe. So there's quite some potential for a number of other countries. Yeah, then we have the carbon removal standards, as this is becoming more and more important to collect the carbon removal value. That has been pretty dynamic in the last 2 years, and with EBC, the most established standard, but also last year the Vera standard or the VCS standard has been implemented. And as you also know, there are many companies that work with Puro. There's also there are cases where people go with ISO. And then on the material side, this is also an established situation. EBC is pretty established. Overall, there is a clear trend to go to quality controlled biochar. Now, let me summarize a few market observations and trends beyond the general growth. The first one, I already said that before. I mean, there are several companies, at least 10, that have been operating systems since several years. The installed base, with an installed base of several to many systems, some of them more than 30. The second is that we are seeing new industrial players entering the space, some with really relevant experience from installations outside Europe. Then we see as another trend that the replacement of fossil carbon in the metallurgic industry is becoming very relevant for the industry. And another trend is that feedstocks other than wood or woody biomass is becoming more relevant. And I'd like to continue on the observations. The CO2 certificates for the valorization of the climate service is becoming more and more important. It is basically, it has become a key element. This being said, today there's quite a number of, or there's quite a volume of biochar that goes into carbon preserving applications, actually even without the valorization of the part, mainly because people use their char their own, and they want kind of the climate service for themselves. And second is that quite an amount of biochar is used produced in smaller systems that are not yet onboarded on a carbon removal certification system. And then what's also clear, the offtake and the usage of biochar is growing, but it remains a challenge to get offtake for all this biochar, and it definitely requires political and regulatory support to be able to get all the biochar into the market. So coming to the summary of the report itself. So the technology is mature. We have at least 10 companies in EU providers. from which at least 4 are at TRL 9, so that means technology readiness level 9, and the others at least at 8. The market is growing strongly and will continue to grow. We have, this is a summary, 53,000 tons of biochar production capacity end of last year, with an actual biochar production of 33,000 tons, equivalent to over 90,000 tons of CO2. Growth rate 56%, expecting the market to grow to above 90,000 tons production capacity and 50,000 tons of biochar production with 150 tons of CO2 equivalent. So we see from the growth rate that biochar is easy to scale, and we can bring that to relevant volumes near term. Now, I would like to hand over quickly to Harald, who will present a few reference projects. Harald, all yours.
Thanks a lot. So I'm happy to say, or to start this saying that it's becoming difficult to select reference projects because there are just so many really interesting ones. Can you just give me all the points? We have selected several reference projects based on kind of the assumptions that Hans-Jörg already mentioned. They have to have multiple projects that are up and running for several years in total, so their experience should be several years, and they should have the proven capacity to produce certified biochar. They are operational or under construction with a relevant, with a significant importance for the sector. And what they should have is a smart utilization of energy. This is something we should be stressing on anyways, in any case, because biomass is needed for producing energy, and we should not let get to waste. And we want to show a representative split regarding the countries that are of greatest relevance for the market. So we start with a small scale project, which is in Switzerland. It's been up and running for several years now. It uses natural wood from forest and landscape management. The production unit is a Biochar. It's rather a small one with 360 tons per year, and they're feeding the energy of 400 kilowatt thermal into a local district heating and a heating network for industry. The next one is from NGE. They have started with sewage sludge carbonization, also going into different directions now. This is a project from last year, and they are using the energy to dry sewage sludge, also a very smart concept, have an overall capacity of 500 tons of biochar from residual forest wood. This one is a large-scale project. It's the large Synkraft unit. It has been commissioned also last year, and it uses residual forest wood. The main focus is on energy production. So it is 11 gigawatt hours of heat for the local district heating network and 7.5 of electricity. And the biochar production, even though it might not be the main focus, it's 1,000 tons per year. So really quite considerable. And this is a very interesting project of Pyreg and Novocarbo as a projector, made as a fully integrated part of industrial processes. Also very interesting. I see several projects now for the future that are integrated in industrial processes. It's the currently largest Pyreg unit, also commissioned last year. And they're feeding 750 kilowatt thermal energy into the company's heating network and producing 700 tons of biochar per year. This is a project that will be finished. It's under construction, will be finished next year. Of Wow, they have 6 of their larger units, the Spirajoule, or the BioGreen, and they use demolition wood as a feedstock, also mentioned before by Hans-Jörg as interesting material because they use it in industrial processes. They have 50 to 60 gigawatt hours of renewable heat annually, and they have a biochar production of 10,000 tons per year. This one is for silicon production. And this is a medium-sized project, but it's a specialized one. It is on sewage sludge carbonization, so worth a mention because it's also a very interesting field. 4,000 tons of sewage sludge are fed in and converted into 400 tons of biochar. And the energy, the thermal energy of 2 gigawatt hours per year is used for district heating, or will be used for a district heating network. The interesting thing here is, and this is also why we mentioned it, is that the biochar from sewage sludge in Denmark, where this plant is situated, is used as a soil improver under Danish law. Also something we're working on as EBI.
Well, perfect. Thanks a lot, Harald, for this nice summary, and it underlines that that what my impression is, or our impression is from the industry, that this is really this has evolved to a really exciting industry with a broad technology offer, and yeah, looking forward to what else is going. As somebody who likes technology, I'm really curious to see what is going on in this direction. Now, so kind of we have the block of why are we doing all that? Then what exactly was the market behaving? Now to the element of the reference project. And now I'd like to kind of do some extrapolation exercises and to discuss what this actually means to us as an industry. And just to start here, and I would like to, because I will later say that biochar is so important, or biochar carbon removal is so important, and it is, but it's not the only one. And we don't want to be the only solution that does carbon removal. This being said, there are many synergies, and I'm particularly interested in the synergy between BECCS and biochar carbon removal, because obviously we can collect the CO2 that goes through the exhaust gas into the atmosphere, also while doing pyrolysis. And there are many other synergies. So very clear, and that has been underlined by the report that had been published maybe 6 weeks ago from leading climate scientists, the State of the CDR report, which, by the way, also used numbers from our report. And we are in contact with the people to be closely connected also on methodology, on how we create our numbers. So very clear, biochar carbon removal plays an important role in the portfolio of carbon removal technologies. And so if you look at this slide, you can hardly find, so I'm converting now biochar production to carbon removal. And what you see here is that the bar, the blue bar in 2023 is still very small. And we start just with a historic biochar production with the numbers you had seen before, converted with a factor of 2.8 tons CO2 per ton of biochar to calculate from biochar to CO2. And then we extrapolate with a growth rate of 70% in this model here. And then you can see if we manage to do that, we will actually end up at just above 6 million tons of CO2 by the year 2030. And I truly believe that maintaining such high growth rates is certainly challenging, but I think it's feasible. And with that, we will reach the Commission's target for industrial carbon removal by 20%. We overachieve by 20%. So their target is 5 million tons of CO2. And now the question is, I mean, how realistic is that? And I mean, there are different angles to the questions, how realistic that is. One of them is, will the industry be capable of producing the number of pyrolysis or biochar production plants required? And by extrapolating the current growth rate with 70%, but also extrapolating that the plants are getting a bit larger year over year, that means that in the year 2030, more than 1,000 new plants would have to be built. And in summary, or in total, over the years from 24 to 2030, it would be just over 3,000 plants. So, well, first we thought, oh, wow, that sounds crazy. Today doing 28 plants, how can we really get to 3,000? Then I looked at for comparison reason, at the 100, at the plants, the medium-sized combustion plants, and that is 1 to 50 megawatt that are installed in Europe. And we find a number of 143,000 units that have been installed or that are currently installed. So in a way, the 3,000 doesn't seem to be, I mean, it is a challenge, but it doesn't seem to be impossible. And the growth rate in the equipment industry in terms of number of equipments is a bit lower because we see that the average size is growing a bit. Now, that was the exercise to extrapolate to 2030, and I even dared to extrapolate to 2030. I didn't dare to extrapolate to 2050, but when we do that, we clearly see that, I mean, there's one rule in exponential growth, that is, it doesn't go forever. So it can be very high in early phases of certain industries. And I think that high growth rates of 70% are feasible near term. But then after 2030, it would have to drop down significantly, because otherwise we would use up all the planet's biomass, and that won't work. But I think assuming a 10 years growth rate at 70%, and then declining growth rate, this is just an example on how that could be modeled. And for sure, it will not happen like this. But for sure, if we could do that, that would bring us to more than 100 million tons by 2040. Short term, the challenge is the high growth rates. And long term, there will be a challenge with the availability of biomass. And I will like to come this as kind of the last slide on this growth trajectory. This is an analysis that was been done by the policy working group of EBI, and this specific graph had been done by Stistal. Thanks a lot for that. They have analyzed the sustainable biomass potential according to different sources, and we find that there are different scenarios, but there are roughly 1,000 million tons of biomass, dry mass available. So now the question is, where should that biomass be used for? I mean, for sure, fossil will have to go away. Biomass is a limited resource, but therefore it's very important that the use of thermal energy from the process the energy is used smartly, because that avoids conflicts over the biomass resource. Second thing that is really important is that biomass gets used in cascades, with pyrolysis as the last step in the life of that biomass, because it optimizes the use of biomass. And last but not least, a huge advantage, and that is certainly not included in that potential here, pyrolysis permits the usage of biomass that otherwise would be difficult to be used. Now we look at, well, you remember the 2030 projection with 6 megatons CO2 projected for biochar carbon removal. And so we looked in what would be the amount of biomass needed to do that. and we'll get out there. It's less than 1%. Actually, the bar would have had to be lower, but it doesn't make a difference. Now, things are getting different when we move to 100 megatons by 2040, and assuming that no additional biomass can be valorized, then this would be equivalent to 90% of the biomass. This being said, if we make the simple rule of thumb, then 50% of the energy would be used for industrial processes or for district heating, for example. Okay, that was everything. And I'd like to conclude with that slide that we believe that biochar carbon removal is capable of delivering carbon removal at climate relevant volumes within 15 years. And this is, from my point of view, also the sweet spot of the biochar carbon removal, that it's within the portfolio of different options. It is certainly the one that in shortest time, 15 years is relatively short, that in shortest times can really deliver climate relevant volumes. Thanks a lot.